Everybody I know is talking about building agents today. It comes with, a lot of good reason. These things are very powerful, but there aren't a lot of good, like actual guides, I would say, from folks who are building agents serve millions of people. But this, I think, is my favorite resource, and I've been meaning to do a video on it for some time now. So it's from the team behind Manus, which if you aren't familiar, you should go check it out. It's like an agent-based ChatGPT, I guess is probably how you describe it. And they put together this super good, very detailed article about essentially all of their learnings and their focus on context engineering. So we're going to go through this article with a bunch of interesting kind of subplots to jump into subtopics. So we'll kind of start from the top. The decision, should we train end-to-end in open source or frontier models using in-context learning? And they said, hey, we're going to bet on context engineering. So spending their time focusing on how to get the right context to the model to let it accomplish its tasks. And we're going to do a whole other video on context engineering versus prompt engineering at some point. And so they said, yeah, basically they wanted to make a bet such that if models get better, Manus would get better. And this is generally how you should position your company, your startup, your whatever, your internal tools that you're working on. You want to make it such that when the models get better, your tool, your product, your service gets that same amount of leverage. If not, you certainly don't want it to be in opposition. You don't want it to be kind of flat either, because you really want to be betting on these things getting better, because there's a huge economic advantage to doing that. And so they focus on, hey, how do we do better shape our context that we send to the model? And they say that the cache hit rate is the single most important metric for AI agents, which I think is really interesting. Not that something you hear too often, because it relates to latency and cost. Latency and cost are still both huge issues today. There's a lot of things you can do on the latency side from different inference providers, things along those lines. And cost kind of just keeps going up, even though the model tokens per million might be decreasing. The LLMs are producing a lot more tokens in general. So the costs are still very much so a huge issue, I think that a lot of agent companies have to figure out. And, maybe not as expected, tokens haven't come down too much in price yet. So let's run through this kind of flow. The agent gets an input. The agent proceeds through a bunch of tool calls to complete the task. In each iteration, the model selects an action from, which basically kind of is like a tool from a certain collection of potential actions. They execute that in a sandbox, a virtual sandbox, and that produces some output, what they call an observation. The action and observation are appended to the context, so added on to the end, forming the input for the next iteration. This loop continues until the task is complete. So this is all happening while the user is just kind of waiting. We're going to look at an example here in a second. Manus, for example, the average input to token ratio is around 100 to 1, which is really crazy. And what that basically means is that, for 100 input tokens, there's a 1 output token. And that's just because of all the context being provided in the input, which continues to grow and grow and grow. Fortunately, context with the identical prefixes can take advantage of the cache, which reduces time to first token. That is really big. Time to first token is a huge UX thing. The user can kind of see something's happening right away. And there's also a bunch of costs. So Sonnet, for example, is from 0.3 to 3, so it's a 10x different. All right, so let's come over here. We'll look at a quick example. So this is really I would say the main graphic throughout the article. And so it says, basically, don't do this on the left. This is where you provide the same instruction, and that does the cache hit, but you start kind of in the n+1 step rather than just starting from the beginning of n. So rather than starting at action 1, observation 1, you start at action 2, observation 2, and that completely messes up the cache because it needs to start with the same exact prefix. Another way to say that is all the context needs to be exactly the same, working from step to step. And this is generally what you would want, where you are appending it to the end and then adding it to the next. So they basically only have to really process the most latest action and observation. Everything else should hit the prefix. And so to bring us into an example, let's say we want to book a flight from New York to Paris. We could have a couple tools in here. For example, if you're not familiar with tools, these are just things you can give to an LLM to be able to actually take certain action rather than just generate text. Searching the web, for example, is a tool. In this case, we're going to have a search flights tool, which we have a name and a description. we pass certain info about like the origin, so on and so forth. And this allows the model to actually search for flights. Same thing with like booking a flight. Book flight, blah, 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 properties, so on and so forth. And so what this could look like is, book a flight. First, it's going to search, and then it's going to find flights. It's going to filter them. It's going to do all this stuff. But at this point, this would be, step, we call it step 3. It's done these things. It's found some information. Then at step 4, we're providing all the same context here, word for word, just copying and pasting it over, and we're just appending the latest action and observation. And it's really important that it's exactly the same, because even just a single token difference will tell the model that, hey, this is different and won't hit the same cache. So if this action 3 for some reason got updated to not have space or something along those lines, that would mean the LLM would have to reprocess everything here. And we can look at a little bit of example. We wrote about this some time ago. So we'll do a quick kind of dive into caching. So the most illustrative example of this is that if the original prompt says act like a financial assistant, and then in prompts down the line you say behave like a financial assistant, even if all the other text is the same, it's not going to hit the cache. And so that's generally the really big key takeaway here. This will save you a bunch of money and make your app a lot, or your agent a lot faster when doing things. And so let's see what else they have to say here. So yeah, keep the prompt prefix stable. A single token difference can mess things up. Common mistakes including a timestamp, especially one precise to the second at the beginning of your system prompt. Sure, yeah. So we've done rundowns on the Claude 4 system prompt, ChatGPT system prompt. There's a bunch in prompt up too, but there's just a bunch out there. You'll usually see like almost always the opening line is something like, hey, today is October 26th at 4:57 p.m. Which is, that's okay, and it gives good context, but that's obviously something that's going to be changing quite often between these steps. And so that alone will invalidate the rest of the cache. Make your context dependent only. Yep, as we saw before, add the steps and them. Avoid modifying previous actions or observations if you can do so. Mark cache breakpoints explicitly when needed. This is annoying. Some providers make you manually say, hey, cache this in particular. So if we come back over here, we can look at a quick example. Yeah, so both Anthropic and Gemini make you cache it manually. We can see if we can look at a code example. I know we have one or two in here. Let's see, yeah. You have to use cache control parameter to mark the parts of your prompt for caching. You can divide up to 4 cache breakpoints in a single prompt, allowing separate reusable sections to be cached independently. And there are like benefits to this, but you would just, OpenAI does it automatically, and I think you'll see them, Anthropic and Gemini, move this. It's just a better user experience, and it's kind of how it should work, right? Like us as developers shouldn't have to think about whether you're caching it or not. We'll follow the rules of making the prefix the same, and then we have that kind of standard there. So for example, we have this like large document that we're appending in the system prompt, and we're going to add cache control, ephemeral, and then we'll cache that. This is, as I mentioned before, with OpenAI, it just does it automatically. So when a request is made, the system basically checks to see if it's already stored in the cache. There's a whole bunch of details about like how long it lasts and like things along those lines, and get pretty intricate. So we'll link to this below if you want to check it out. Moving forward here, mask don't remove. So if you're building an agent, you're obviously using a bunch of different tools. And as they mentioned, trust me, someone will inevitably plug hundreds of mysterious tools into your action space. I could definitely see that making sense, especially with MCP being a lot easier to plug in tools. Framework there's a clear rule: unless absolutely necessary, avoid dynamically adding or removing tools mid-iteration. And I think what's really more important here is like, this is the same exact advice as, where was it? Avoid modifying previous actions or observations. It really is the same flavor of that, but just with tools. And so in this case, we could see there are different tools added. Tool C and tool A is removed. And so that obviously breaks the cache, right? The only thing that would be get cached in this case would be the instructions. And in this case, we're just going to mask it, and then it's included, and we have the same exact prefix the whole time. There are also, as a note, like hallucination issues in this setup on the left, where we see we have action 1 and observation 1 are made when they have tool A and tool B. Now the model's receiving all of this. If those were derived using tool A, it's going to be very confusing to the model that, hey, you got to this observation and you said use this tool, but I don't see this tool anymore. So it can lead to kind of really bad situations like that as well. That. And file system as context. So we'll pop over here for a quick second. So as user conversations get really long, think of ChatGPT, you could have a user and assistant going back and forth for however long. Models have a limited context window, even though they are talking about being millions of tokens long now. I think they're much less effective than that. We've talked about this a lot before. A good benchmark that I like to look at is Fiction Live. And we like to look at this because it's not a needle in a haystack. So it is a narrative kind of comprehension style type of test where it says, I'm going to give you a story, then you're going to answer a question about it. Gives the story, finish the sentence, blah, 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 what names of Jerome list. And so this is really not so much about retrieval, which LLMs are a lot better about, a little bit more about comprehension. And if we come over here and look at the results, they're not, first of all, they're not great across the board. So GPT-5 does a pretty good job going from 100, keeping 87.5 like performance relative, I think is pretty good. That's also almost a 14 point drop, which is very noticeable, especially if you start like stacking these things up. O3 goes from 100 to 58 at 192K. And that's a lot of context. I think that the bigger problem is just the like advertising of these context windows being 1 million, 2 million tokens. And we just don't have data that the models are actually effective at doing that. So maybe we should focus on making them actually effective at the lower levels first. Google is really good at this stuff generally, which makes a lot of sense. It's just like a big data thing. So 25 Pro goes from 100 to 90.6. Be really interested to see what Gemini 3 does. And I think Grok is pretty good at it as well. Yeah, Grok goes from 100 to 97 at 120K. That's like really solid, I would say. But again, we're not talking about like crazy big context windows here. We're talking about 120K tokens, where these agents can be really long running, call lots of tools, receive a lot of data, files. Like these can fill up kind of pretty quickly when you're having them do a lot of different complex tasks. And so that means you got to do something about it. So again, message history could be, there could be like tools and stuff in here as well. So tools, call this like files, search, whatever, so on and so forth. So eventually you have to do something about it. And there's a couple ways you can do this. For example, if this red is all 128K tokens, what you could do is for the next user question, maybe only bring in the last 32,000 tokens. So this thing called the sliding window, where you're basically just bringing in, with the system instructions, the last most recent bit. Another option is to condense, compact, summarize, which different ways to call it, where you're basically taking the whole history and at some point squeezing it down, having the LM create a summary such that it's basically look like summary and then the new user message. Okay, so with that, let's go back. So yeah, as it's saying, the world, enough tokens, sometimes the liability observations can be really big. Yep, auto performance tends to degrade. Yep, and long inputs are expensive. Yep, we didn't touch on that, but obviously the more inputs you're sending, that's gonna cost you money. More tokens that you send, even with the data cache. So to deal with this, a lot of systems implement truncation or compression, but overly aggressive compression can lead to information loss. And this, of course, true. Anytime you're summarizing or condensing something that's really big into something that's small, you have the potential to lose context that's actually relevant. So what they do is they treat the file system as the ultimate context. In Manus, so the model learns to write to and read from files on demand, using the file system not just as storage, but as structured externalized memory. And so in this case, rather than having these big observations, you see it's breaking it down into sending it out to these different documents that it can read to and write from consistently. And so it gives the model a little bit more agency in terms of determining what it thinks it should learn and kind of keep in its memory, rather than just summarizing and condensing things down. And so this is a really interesting approach. We've seen this kind of happen or used with Anthropic. They'll talk a lot about a scratch pad. They'll give the model to kind of jot its jot some information down. It kind of just takes it to the next level with the whole file system. And so I think it's really cool. Moving on. So yeah, this was, at the time, was like the only person that was really doing it was Manus, but this like to-do file, which if you use Claude or GPT-5 and something like Cursor, you're seeing a lot more of this now, where the model will generate a to-do, like at the beginning. And GPT-5 in particular is really trained to do this, to set up a plan from the start and have all these different steps it wants to go through. There's definitely been like post-training on that. We've written about it. It's in the cookbooks from OpenAI, so this isn't like a secret. But basically, it prints this, updates progress, and checks off complete item. It's not cute behavior, although it is cute, but it's a mechanism to manipulate the attention of the model. So rather than just having all the objectives up front and then saying, go and do all the things, basically just going to reinforce those objectives periodically, maybe as certain actions happen, so then the model can remember what needs to be done. And they append it to the end to avoid the losing the middle or lost in the middle aspect of things. Typical task in Manus requires about 50 tool calls. That's a long loop. It's vulnerable from drifting. So the objectives help keep it on track and avoid drifting. So that's another fun one. It makes a lot of sense. It is being baked more into the models now. I see a lot of these best practices, whether it's chain of thought, something like this to do, eventually kind of the really good ones, the ones that actually make a difference, end up being inserted into the models in some way or trained into the model sites, which is pretty cool. Moving on, keep the wrong stuff in. Yeah, this one's pretty straightforward. Basically, you don't want to remove errors that the agent makes because it can learn from that, and in later requests can see things that had failed. So agent makes a mistake, that's not a bug, it's reality. LMs hallucinate, that's not going anywhere. Failure is not the exception, it's part of the loop. These agents, when they're doing these large tasks, tend to make mistakes. So erasing blah, blah, blah. So yeah, you don't want to remove these things. You want to keep these in, and then it can learn from those mistakes and make better decisions. So leave the wrong terms in the context, blah, 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 so on and so forth. And then don't get few shotted. Few shots, common technique in prompt engineering. You give examples to the model of similar types of tasks, and then you give it the task itself. But we've talked about this a lot before. It's not great for just reasoning models in general, but also, of course, agents, which are kind of extrapolation of reasoning models. And this is mostly because of overfitting. So if we come back over here, let's do imitate the pattern, blah, blah. Yeah, increase diversity. Yeah, so with few shot prompting, 5 kind of principles to keep in mind. You really could kind of get this down actually just to maybe 1 or 2. You need to use at least 2 examples. Again, because if you only use 1, it will probably overfit on that example. You got to be diverse. You got to show many different examples. The examples need to be diverse. You should have positive and negative examples or a variety of examples. It should be ordered randomly. Like you shouldn't really be trying to show a pattern. You should make sure that they follow the same format. So an example here, if we're classifying movie feedback, if we're saying, hey, the goal is to classify the following feedback, and let's say here's the feedback. Then we here send our examples. Movie was good, bad, very bad, amazing. So positive, negative, negative, positive. This is pretty good. A bad example, and this could be a lot better to be honest, but whatever. Bad example would be something like this, where you're saying movie is good, that's positive, movie is amazing, that's positive. The model would be smart enough to know that if you passed feedback that said, hey, the movie's crappy, hey, that's negative feedback. But they're kind of only showing the model one success case, and that's only when the output produced is positive. So again, that's kind of this overfitting problem where we've seen this a lot too, where if you see a specific failure case, just jamming that in the examples will maybe solve that one failure case. It might solve that one failure case, but it might overfit other cases and make other issues pop up elsewhere where it's now falling too closely to that failure case example and can solve that, but now isn't like enough to generalize. And so that's why we generally say that when you're using, especially agents, reasoning models, you don't want to do few shot prompting, because what makes these things great is their ability to be adaptive. And few shot prompting can just be naturally them overfit. You want them to go out and have the tools and everything to kind of just let them cook, honestly. And so having these examples is not really helpful in that case. And yeah, that is about it. This was super helpful. Shout out to the Manus team for putting this together. Everything will be linked below, and I hope this helps you build better agents.